Today, let's pick another problem, that is maximum subarray, which is the fifth problem from the top 50 data structures and algorithms. So the problem is that given an integer array nums, find the subarray with the largest sum and return its sum. Okay. So we'll see this problem in different contexts, and what kind of solutions we can find, and also we'll discuss the solutions as well. Okay, we'll take the first example, this one, and we'll try to see the, as usual, like a brute force approach is the first one, and then we will see the one more optimized solution. We'll see what is the other solution as well. Okay, so coming to this problem, so we will take the same nums whatever we have here. Nums are like -2, 1, 3, sorry, -3, 4, 1, 2, 1, -5, and 4. Okay, so these are the numbers given. So what we need to find is we need to find the subarray with the largest sum. Okay, that's what we need to do. So in the example one, whatever they mentioned here, the subarray is 4 minus 1 2 1. This is the subarray actually which gives the largest sum, that is 6, right? So for our example, we will see the first one is solution will be brute force. Okay. Okay, let me erase this. So first solution, as usual, we'll try to see the brute force. With the brute force approach, what we can do is we will take the um, uh, we'll take the two for loops to solve this problem. First, what we will do is we will try to start from iterating from here, and then we will follow the remaining numbers by adding all the numbers and see the maximum sum we got or not. When this is I is done here, let's move to I position here, and j will be starting from here to here. Similarly, like keep going like that till this number, right? We'll see that what is the maximum sum we receive. That is how actually solution could be, right? Let us iterate this one. We'll take two variables. One is like a maximum sum. Maximum sum initially we will initialize with minus infinity. Okay. Uh, this is what we will do, initialization. Then we'll try to check the position from I equal to 0, and j also will start from here. Okay. So what we will do is we'll take the current sum. Okay. We'll take this one -2. Okay. -2. I will be here only. Just will try to add -2 with the current sum. Okay. Basically, current sum will be 0 initially. When I starts from here, then we'll take the nums of j. Basically, nums of j is -2. So current sum is -2. Okay. And then we'll check. Sorry. We'll see that I equal to 0 and j equal to 0. What will be the like a maximum sum and current sum actually? Okay, current sum will initialize with 0 initially. So when I equal to 0 and j starts from 0, right? So we'll take the current sum equal to, in this position it's a -2, and also we'll compare with the maximum sum on this one, which is the maximum sum is minus infinity and current sum is minus 2. What is the maximum value here? Minus 2, right? Minus infinity is bigger than this one, sorry, smaller than this one, so we need to take minus 2. So now maximum sum will be equal to minus 2. This is at j equal to 0, so I will be like 0 only. So now we'll increment the j position to here. Okay, I will be here only, j will be now 1. Now what we will do, we will try to add I equal to 0 only, j equal to 1. So now current sum will be minus 2 plus 1, that is minus 1, right? So maximum sum also minus 1, because minus 2 and minus 1 compare, minus 1 is the bigger one. Okay. So now what we will do, uh, now I remains same and j equal to 1, j will be here now. This is minus 3, j equal to uh, j equal to 2. So now minus 3 and current sum is minus 1. Minus 3 minus 1 minus 4. Okay. And minus 1 is the maximum than minus 4. So minus 1 remains here only. So now j will be here. Okay. Now, now what happened? I remains 0 and j will be 3. I mean 3 means this position. Now we'll see like minus 4 plus 4, that is 0. Now maximum sum will be minus 1 and 0, which is the greater, 0 is the greater. So maximum sum will be 0. Now I will move here and j value is 4. 0 plus 1 is 1 and 1 and 0, which is greater, 1 is the greater. Similarly, we'll move here. Now compare 2. Uh, this is the position 5. Now 2 plus 1 is 3 and 1 and 3, which is the greater, 3 is the greater. Okay, now j will move here and sixth position. Now 3 plus 1 is 4 and 3 and 4, which is the greater, 4 is the greater. Now we'll move here, current sum will become minus 5 4, that is seventh position, and which will become minus 1 and which is greater, and 4 is the greater. Similarly, when we come to this position now, and eighth position, minus 1 plus 4, that is equal to 3, and which is greater, 4 is the greater. So in this case we got the maximum sum is the 4 is the greatest value, and current sum anyway will leave it. This is the when I equal to 0. So now we'll move I equal to 1 and j remains start from 1. Okay, let us see like what happens. Currently as of now maximum sum is 4. 4, that's what we got, right? I think let's move to, oops. Okay, basically I need these values. Let me see, I can copy this. Okay, so when I equal to 1 and j also starts from 1. Okay, so from here we'll see what happens. Currently as of now maximum sum is equal to 4 we got, and we will initialize the current sum to 0 now in this position. Okay, so now what happened, we'll see, we'll pick this value 1. Okay, current sum will become 1 here. Okay, 1 will initialize and then we'll take this value now 1, and current sum plus 1 is 1. 1 plus 1 and 4, which is greater, 4 is greater, less remains same only. Now j equal to 2, the 2 value is minus 3, right? Now 1 minus 3, that is minus 2, current sum will become minus 2, and this is still 4. Next value is 4. Now what we got? Minus 2. This one is 3 minus 2 plus 4 is 2, and this will become 4 only. Next, take one more number is 1, that is 2 plus 1 is 3. This is the greater. Next one is 2. This fifth position we have 2. 3 plus 2 is 5, and which is greater? 5 is greater. Next number is 1. Then we'll take the sixth position is 1, and 5 plus 1 is 6. Sorry, 5 plus 1 is 6. Which is greater? 6 is the greater. Next number is minus 5. 6 minus 5 is seventh position, minus 1. Minus 1 and 6, greater is 6. Next position is 4. Minus 1 plus 4 is 3, and 6 is the greater. Okay. Yeah. So let us move this one to, oops. So till now we got 6 is the greatest, right? 6 is the greatest. Let us move. I will just take the just values to here. Okay. So now we got in this position, actually we are at I equal to 1, right? I equal to 1, and I equal to 1, and maximum sum we got is here is 6, basically, right? In the when I equal to 1. So now what we will do, here just taking out I equal to, now 1 is done, and I equal to 2, and j equal to, start from 2 only. As per now, we got the maximum sum as 6, and current sum is 0. But anyway, we'll take this one 0, that is equal to minus 3 will come in this position. Okay, 0 plus minus 3 is minus 3, and minus 3 and 6 compare, 6 is the greater. That's it. Okay. Now j value will become increment, that will become 4, and minus 3 plus 4 is 1, and the 6 is the greater again here. Next value is this is done, and this will be 1. 1 plus 1 is 2, current sum is 2, and maximum sum is still 6. And then we'll take next value as a 2, that is 2 plus 2 is this is 2, 3, 4, 5, and we'll take the sixth position, sorry, 4 is nothing but 2, 3, 4, fifth index basically. At fifth index is 2, 3, 4, 5. This is the 2. 2 plus 2 is 4, and maximum sum still 6. And 6 position 6 we will get 1 plus 4 is the 5, and maximum sum is 6. Next, this seventh position will get minus 5, that will become 0, still 6. And at eighth position 4, 0 plus 4 is 4, and this will become 6. Okay. So this is the when j equal to 2, still max sum is 6, sorry, I equal to 2, and remaining all the arrays will j just move on. So another case is that I equal to 3, and j also starts from 3. In this case, current sum will become 4. Current sum equal to 4, and maximum sum last time we got is 6, right? So 4 and 6 compare, 6 is the maximum value. So to index 4 we have 1, 1 plus 4 is 5, 6 is the maximum. And at index 5 and x5 we have 2, sorry, minus 3, 4, okay, plus 1, 5, I equal to 3, 0, 1, 2, 3, 4, maximum sum equal to 6, yes. Now at position 4, 1 is there, 4 plus 1 is 5, okay, 5, 5 and 6, 6 is the maximum, okay. At position 5 we have 2, 5 plus 2 is 7. Is this input correct? This is minus 1 actually, sorry to say that. This is minus 1. So 4 plus 6, 6 is the maximum. 4 minus 1 is 3. Okay, and now 3 and 6, 6 is the maximum. And seventh position, what we can do is we have to minus 3 plus 2 is 5. 5 plus 6 is 6. 5 and 6, max is 6. Next, move on to 6. 5 plus at 6 position, 5 plus 1 is 6. 6 and 6, maximum 6 only. Next, seventh position, 6 minus 5 is 1. 1 and 6, 6. And 1 at eighth position, 4. 1 plus 4 is 5. And maximum is 6. So this is the case where I equal to 3. Let us take the I equal to 4 and j also start from 4. At fourth position, the current sum will become minus 1 and maximum sum is 6 already. So we'll move from here to remaining elements. Now what we can do is j equal to 5, that is this position, and minus 1 plus 2 is 1 and 6 is the maximum. At position 6, 1 plus 1 is 2 and max is 6. At 7, minus 5, 2 minus 7 is minus 3 and 6. At position 8, minus 3 plus 4 is plus 1 but still 6. Okay. Next, when I here maximum is equal to anyway 6 only. At position 5, j equal to starts from 5 and the current sum is equal to this one 2. Maximum anyway, maximum is equal to 6 only. This is what we received previously. Now at position 6, 2 plus 1 is 3 and maximum is 6. At position 7, minus 5 plus 3 is minus 2. Maximum still 6. At position 8, minus 2 minus 4 uh, plus 4, that is 2 and max again 6. So let's move on to I equal to 6 and j is equal to 6 and current sum is equal to 1 and maximum sum anyway previously we got 6 and j equal to 7. 1 minus 5 is minus 4, maximum is 6. At position 8, 4 minus 4 minus 4 plus 4 0 and maximum is 0. Similarly, we'll try to get it out from I equal to 7 and j start from 7 to above this one and maximum current sum is equal to minus 5. Okay, and maximum last time we got is actually 6. At position 8, minus 5 plus 4 is minus 1 and this is the 6. At the end, at the end again, and I equal to 8, j equal to 8, and current sum is equal to 4, max sum is equal to 6, because 6 is greater than 4, and max sum last time we got is 6. So maximum sum, actually using brute force we can return the 6 is the maximum sum. Okay, this is the first solution whatever we spoke. There is another solution. uh, 1 minute, I will just check this. Yeah, second solution is second solution is actually, there is a name called uh, Cardan's algorithm. We'll see what is this. Cardan's algorithm. We'll just Google what is this. So this guy defined some algorithm actually to just you need to, are you able to pick the right number or not. That's what it will show without using any extra space. Okay, so you can just have a look. This is the subarray problem, also known as magnum segment subproblem. Is the task finding the continuous subarray with the largest sum within a given one dimensional array. Okay, so we'll discuss this one now, how it works. This algorithm will take actually O of n time complexity. This is O of n square. Let me write here brute force. This will take O of n square, and this one we are planning to implement using O of n only, and just constants, s- space as well. Okay, so we'll take same input actually, whatever input we have. Let me write. Okay. Okay, this here what this guy says is that here we need to 4 minus 1, this one minus 1. So here what we can do is we need to define, we need to take the number. If you take the number, what is the result? Like that actually we need to take care. For example, what we will do here is we will try to take the maximum sum is equal to minus infinity as we saw earlier, and current sum probably we can take it as a 0. Okay, so what we will do is we will try to take this number, first number, and check from this number and current sum plus this number, whichever is the maximum, take that one as a current sum. In this case, current sum is minus 2, current sum is 0 plus minus 2, that is minus 2, which is the maximum 0. Basically what I'm talking here is, take the first step for current sum. What we need to do is current sum, this is the default installation. Current sum is equal to maximum of minus 2 comma 0 plus minus 2, which is the maximum number. Minus 2, 0 plus minus 2 is a minus 2. So at the first position the value of the current sum will be minus 2. Okay, I will write here minus 2 at the position 0, when the I is 0, where when here what will be the maximum sum now. We need to see the maximum sum is equal to max of current sum and max sum. So current sum what we got now, minus 2. What is the minus maximum sum currently? It is minus infinity, so it will also become minus 2 when I is 0. Okay, that's it. So when I become 1, what we need to do is, this is the 1, right? So we need to again check it out. I will erase this one so that I will write down again formula what we are trying to do. So here what we need to do is we need to check current sum is equal to what is the num actual at the ith position is 1, and current sum is minus 2, plus what is the num actually at that time, 1, right? So here what we will get, 1 comma minus 1, 1 comma minus 1, which is the maximum value, 1 is the maximum value. So the current sum will become 1, and maximum sum currently, here actually I want to do, this is initialization basically, and previous, okay, 1 minute. Okay, let me write here once again, sorry for that. Current sum and maximum sum we have already derived for the 0th position, that is current sum is minus 2 and maximum sum also minus 2. Okay, and when we are 1, we need to see what is the maximum value of minus 2. Basically we need to apply this formula. I will keep deleting. Current sum is equal to num at position 1, that is 1 comma minus 2 current sum plus 1. Okay, this is what the algorithm says. So currently what is the maximum value, 1 minus 1 is 1, so we will get 1 here, and maximum sum is actually um, the max value of current sum and maximum sum, so it will become 1. Let me erase these things. Okay, so now let us move on to the I is 2 now, that is minus 2 minus 3. So current sum will become nums of I is minus 3 comma currently is 1 minus 3. So whatever the maximum value we have here, minus 3 comma minus 2, that is minus 2. So current sum will become minus 2, or maximum sum will be max of minus 2 comma 1, that is 1. Let's move on to 3, position 3, that is 4. So what we can do is here, what we need to do to calculate current sum. So let us take position 3 is, it is 4 comma minus 2 plus 4, that is equal to 4 comma minus 4 comma 2, which is the maximum, 4 is the maximum. So current sum will be 4, and now compare maximum sum of 4 and 6, it will be 4, right? Now let's move on to next position, that is 4 and minus 1. So now what we will do, minus 1 comma 4 minus 1, that is minus 1 comma 3, which is the maximum, 3 is the maximum in this position. Current sum will be 3, compare with this 2, 4 is the maximum. At position 5, that is a 2, that is 2. Now you compare with 2 comma uh, 3 plus 2, that is 5, which is the maximum, 5 is the maximum. So now current sum is 5, and max sum also will become 5 because this and this greater value is 5. Next will be 6. Sixth position is this one, 5 plus 1, will compare with 5 comma 5 plus 1, max value will be 6, current sum is 6, and max and current max sum and current sum you compare, 6 is the maximum, so 6 will come here. Let's move on to 7 position, it is minus 5. Now 6 minus minus 5 comma 6 minus 5, that is minus 5 comma 1, which is greater, 1 is the greater. So here we compare these two numbers, 6 is the maximum. Now at the eighth position we can compare 1 comma 1 comma 1 plus 4, which is the maximum. It is the 5, 5 is the maximum. And now the maximum value between 5 and 6 is 6. So 6 is the maximum value which will return. Same value we got even in brute force also. So this is the cadence algorithm approach, and this will be O of n, and space also O of 1 actually constant. We are not using any extra. So let us try to implement these algorithms, both the algorithms here. We'll see. We'll try to approach the try to write the brute force first, and then we'll go for the other approach. Okay. So now what we will do is we'll try to create the maximum, which is equal to math dot int 32 min. Okay. So they very simple actually. We'll try to initialize the 0 I less than length of nums and I plus plus. As we discussed current sum, we will try to initialize. I will take simple variable y2 complex. Current sum will be initialized to 0. Here what we will do is for j equal to, will start from I, and j will be less than length of nums j plus plus, and current sum will be equal to nums of j. Okay, and maximum sum will be equal to max of maximum sum comma current sum, whatever we calculated as of now. Okay, I will take one helper method, func max a comma b int, and it will return int if a greater than b, return j, otherwise return b. Okay, so this is the simple one. We'll let us run this and see any problems comes. Mm, 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 mm. What it is saying? Okay, sorry. Min int 32. Okay, let me check this will work or not. Oh, it will return well, right? Sorry, return maximum sum. That's it. Okay. So this is the, yeah, this will work. This works, and this algorithm time complexity is of n square, right? This is what we discuss. So we'll go ahead and see another solution. Uh, Whatever we discussed, right? That is a Cardenas algorithm. So Cardenas algorithm is also very simple. And for now, we will initialize the current sum also with 0. Let us return that value. That's fine. So in this case, what we will do is for I equal to 0, I less than length of nums I plus plus. It's very straightforward. What we will do is current sum is equal to, we'll see max of nums of I comma current sum plus nums of I. This is what we discussed in our approach. Okay, and maximum sum is same thing, max of current sum comma max sum. or maximum comma current sum. Anything is fine. This much only, 2 lines only, nothing required here. Okay, and let us run this. Code is just 2 lines, but understanding is a tricky thing. Okay, yep, all things are good.